Exit.
We are live for the next episode of the Netdata Office Hours. As usual, we give just a couple of minutes before we start. So just bear with us for some minutes and we'll jump straight to the good stuff that we have to share. As usual, I'll share the presentation on the chat. So I'm putting now the link to the presentation. You can follow it on your own. So I see we already have a couple of people joining the stream, so welcome to the Netdata Office Hours. We probably can get started. I'll just start with the intro. So let me just share my screen. So for show on stream, sorry, I didn't come up. So for today's topic of office hours, we are bringing up more cool things we are working on functions. So we are bringing some useful tools that we believe can power up your troubleshooting toolkit using just the Netdata dashboard. Everything together with the matrix, everything is at your hand's grasp with some clicks. So and with further ado, we probably can go straight to that. So this is going to be the topic of today's session. So we'll cover the spotlight, and then we usually have that open slot for questions for you, any questions that come from the community or from the audience. And we close with a couple of things we found interesting raised by the community, either on the forums, Discord, or GitHub, that might be helpful to others. So for the spotlight, so the two topics is the newly added functions. So we'll go through each one of those that were recently added, and also we'll try to ask for your feedback and also ask for suggestions of things that you would like to see there available on functions. And then we'll be exploiting the way we are using systemd journal logs for Netdata agent events. So let's also have a teaser of something that will go live on today's nightly, and you will be able to use it yourself. So as an intro, we've been adding a couple of new functions to Netdata. If you remember, we started with processes, streaming, and the most recent one, the systemd journal, that is bringing logs into Netdata. But we are leveraging the wide range of collectors and metrics that Netdata has available, and we are bringing them in a different visual representation. So hopefully, and we believe this kind of a viewing of these metrics that you already have on charts and you already see on the dashboards. Showing them in runtime in a table format will be, in some cases, more helpful for you to troubleshoot. So in terms of plans around functions, let's say on the short term, we'll be keeping adding some of these hopefully helpful functions. So grabbing metrics that we have already on charts, exposing them through functions on the functions tab. And hopefully on the long term, we want to expand this functionality to potentially allow to take some snapshots and storing those kind of snapshots. And this kind of thing could be triggered based on alerts. So you have an alert that triggered, and you would like to know what were the processes, what were the status of the network interfaces when that alert triggered, or through a periodic configuration. This is still a bit open-ended, but we know we have already some feedback from community that this kind of snapshots of results of functions is an interesting thing, but we'll see. This is a bit of long-term. For sure, the short-term is something we'll keep working on. In case you don't know, we already have a discussion open on GitHub. So if you have comments, if you have feedback or suggestions, feel free to jump on that discussion. We'll be, of course, monitoring this closely because we believe this is really a powerful feature that we have available on Netdata, and we will gladly like to hear your needs and your feedback on this. Here you have kind of a list of the things that are available, but instead of me going through this list, we'll jump directly to the demo, so you can refer to this when you look into the presentation. So you can see what is a function, what is the alternative CLI tool that it should be replacing in a way. So we have basically all of these new functions that were added. So as I mentioned, let's probably start with the demo because we'll be speaking about this on the demo, and I'll pass it on to Costa to show us.
Hello, guys. I hope you are okay today. So here we are with another Netdata Office Hours. You know, we have been working hard to bring some new features to Netdata. So there are quite a few currently I want to show you. So the first thing is that we added a number of functions. I remind you that functions is the ability of Netdata collectors to actually query stuff at runtime, not metric stuff, upon request. So it's like a collector being able to answer special requests about something interesting. So the first thing is that for all the collectors that collect multiple stuffs of something, like you see block devices, VMs, IPMI sensors, network interfaces. So all these are collectors that already exist in the data, and they contribute charts, so you can see their charts in the data. Here it's like, it's a different view. It's like lists. So if you see here, this is the block devices. You can go here and actually see all the block devices, and you can see the current read rate. If you hit play, these are being updated, writes, etc., etc. This was the same idea of the original process. This is how we started. Oh, Ilya started the thing. Let me see. So the original idea was this: the processes that shows this is the apps plugin that has the application section in the data. And this actually gives all the processes the running process of the system. One of the things that is missing from this has a lot of columns. Of course, it's everything about every process. So all this information that exists in charts is already here as a table. Now, one of the things that is interesting and is missing is that here, of course, you have for per PID for every process that runs in the system. You have CPU, memory, even I/O, physical reads and writes, uptime, and the tone, major faults, page faults, file descriptors that are open, everything, everything related to it. The one thing that is missing is the network I/O, so the network bandwidth this PID uses. Now, this information, we have this information from eBPF. So our eBPF collector is able to expose, to add 2 columns actually here, per PID to show the current bandwidth consumption of that PID. The problem with eBPF is that this specific module seems to be buggy in some versions of the kernel. So there are some exotic versions of the kernel that they become unstable when we enable this. And this is why it is disabled by default. So we're working to actually figure out how we can stabilize the thing so that we're going to have this information also per PID. Another interesting thing that the future of the processes is about, mainly because we have for every PID all the sockets that has in and out, then we can build a dependency tree between services and servers. So we can say, okay, since this server, this PID connects to that thing over there, so it depends on that. So we are thinking of creating a network viewer, let's say, at the IP level of the dependencies between the servers and an automatic map. But okay, this is more to come later. Now, for the moment, we added block devices, so all the disks, containers and VMs that are running. With this is equal, almost equal. Actually, we have more information that systemd CG top. If you run systemd CG top, you can see all the VMs and containers running on the system together with the system services. And actually, we added also the services here. So the combination of this and containers and VMs is what systemd CG top is doing. For us, this has a lot more information. So we have also origin rights and a lot more information that the systemd CG top does not have. Then we have, if this is a physical server like this one that I'm viewing now, we have IPMI sensors, so all the sensors with the values, and there is coloring if something is warning or whatever. We have the mount points. This is DF, DF minus H. This is it. How many mount points you have, what file system it is, the used capacity, the available capacity, etc. We have all the network interfaces and the bandwidth they currently use, in, out, packets in, out, drops in, out. We added this is also interesting. This is the list units. So if I remember correctly, this command, this systemctl
List units.
Systemctl list units. This is why we named it the same. So systemctl list units gives you this list. Now, what we did here is that we did the same coloring that thing has. Actually, for all this stuff, we have a lot more information inside that we don't know yet what to do with it. But anyway, I think that as we use it, the first thing is that you can see the status of every service, the systemd service, systemd unit, including sockets. So here I think they are. So these are the states, yes, the types. So you can say all the mounts that I have, all the services that I have, all the targets that I have, sockets that I have, etc. So this is the units, and the streaming, of course, has been released. This shows all the streaming connections this node has, incoming and outgoing. So if it is a parent, it shows also all the children, but if it streams also outgoing, it shows also the outgoing, together with statuses, etc. And a lot of work has been done on removing the logs of Netdata to systemd journal. So what happens now, you remember that Netdata logs into var log Netdata, error log, collector log, health log, and all this kind of stuff. Now, what we did is that if Netdata runs under systemd, it logs all its logs to systemd. And I think this is going to be released in the nightly tomorrow, so it is already merged today. We're just fixing a couple of minor things that remain. And I think it's going to have a namespace, right, Leah? It's going to be with a namespace. Yes. So the idea is that all the logs, in order not to bother to pollute, let's say, the system logs with Netdata logs, all the logs are in a journal namespace called Netdata, of course. Now, what happens here is that the first thing that we added, and this is interesting to see, the first is that there are a few fields that start with ND, Netdata. All these are alerts, log sources, even if something is about a chart, so you can say something has been logged about this, an alert in this case, about this chart. You can see them in logs. But what is interesting is that we enhanced the journal systemd journal plugin of Netdata to support this. Now, this thing, when processes log to systemd to journal, what they do is that they can assign a specific message ID. Message ID is a GUID, it's a big, a hex thing that uniquely identifies the kind of log. So now you can see here, for example, that if you want to see all Netdata alert transitions, so we use that feature, of course, you just click here and you have all the Netdata alert transitions. The coloring is based on severity, so this is a warning. This is a clear. No, this is an undefined. This went to grayed this way because it's grayed out. So the idea is that in the same way you can see notifications, but also on this list you can see units started or units stopped, or if it is a laptop that you close the lid, that you reboot it, whatever happens, even core dumps. If something core dumps, you're going to have here an item saying a core dump. This allows you, this across all applications, it's not just Netdata, this is standard systemd journal functionality. Most of the events here are systemd generated. So Netdata just added its own. Now, in Netdata, the logging is separated in how Netdata logs it by itself. Is separated into a few sources, let's say. So you can see the sources and the source. Where is it? And the log source. So we have the daemon. This is the Netdata daemon that logs something. This is the health, everything related to alerts and the health. And this is collectors, everything related to collectors. You see, cannot permission denied for something, etc., etc. So the idea is that you can see all the Netdata logs from that thing. Now, the interesting part, let's go, for example, to see an alert. Let's go here and select the alert transitions and click on one. Now here, we used the systemd journal functionality to actually enrich this thing with everything we have. So this includes, of course, internal debugging stuff that we need, like where in the code this comes from. Now we have an invocation ID. So every time you start Netdata, actually this is true for any systemd service, it gets a unique invocation ID. So you can search by invocation ID and to get all the logs of a specific session of an application. We use this, of course. So every time you restart Netdata, it will get a new invocation ID. And so you can see all one session of Netdata, all the logs of one session of Netdata with this. Then you will see the message. The message is what you see in this area. The message ID, that means Netdata alert transition. Now you can see here the details about the alert. So the class, the component, the hash of the configuration that generated this, what is the info, what is this alert is about, the alert name, These are timestamps, etc. The recipient is silent in this case. The alert status is clear. It wasn't initialized. We just restarted that thing. We installed that PR to show it to you. The alert summary, the alert transition ID. This is what we usually have as a link where we click on an alert. This is how we found the alert back. So the units, etc. So this information, even about the, you see it's the log source health. It comes from this context of this instance on this node. So all the information that we have about this specific event is logged in fields. Now, all this stuff are searchable. So if you check what this thing has done, and you can see all the alerts that have been generated with this idea. So whatever you see, all the network, the different network interfaces that use the same alert config in this case. And the same is true even for invocation ID. Of course, invocation ID again, this will show all the logs of Netdata. So the idea is that this way you can view what is happening on your Netdata using the systemd journal logs. Now, one of the most important things why we wanted this to happen is because we believe that the systemd journal is amazing for, especially for developers, but also for operators, because it allows all these amazing fields, all of which are indexed. This is the key benefit that this log management solution has over any other log solution, including Elastic or Loki or Splunk, etc. So the idea here is that as an application developer or as an operator, you don't have just a message, but you have a lot of fields, and all of them are indexed. So if you want to find whatever, even if the logs are really a lot, this thing performs very well. Now, among the others, so this is the new log management. But I didn't tell you that if you don't want this to work in journal, Netdata still generates the old files, not in parallel, of course, either or. It's a configuration option. So now if you go, let me find this GitHub. I think I have a readme in log, libnetdata. I'm not sure it managed to be on the learn yet. So log. Yes, now this describes the new logging mechanism. So the outputs we support is journal. By default is on when you view, when the data starts under systemd. But we also support syslog. Systemd means whatever std or std out, or you can specify one of the two, or a file name. Now, the log format that we support is the journal format. The log format that modern applications usually use, this is key equals value, key equals value, key equals value, and the JSON. So Netdata can output its log in JSON. The log levels that we log, and the log configuration is similar to what it was. This was renamed from error to daemon. That's the only difference. Of course, it's backward compatible. So if you have configured error, it will be automatically renamed to daemon. What is interesting is that now we allow for every source, so you can go to daemon here, and actually you can configure the daemon like this. So whatever you see here, the journal is at the output level, is this part, the output part. But you can say that you want one of the log formats. So I want a JSON. I want only above this level, so log errors and above. This is a flood protection that Netdata has. So I want that up to that many logs in this period, and put the output in that file, or send them to journal, or send them to syslog, or whatever. So this allows total control over how Netdata logs. The log sources, where is it? It was at the beginning, I think, log sources. The log sources are this. So you have the daemon, whatever the Netdata daemon logs, the collector, that means all the plugins, whatever the plugins log, the access log, that is the transaction log of all the API of Netdata, whatever HTTP request receives, etc. And the health log, that it is all the alert transitions. So access log and health, all the logs are structured now. So we have here a list of all the fields. So this is, I don't know, how can I resize that thing? Yeah, anyway, there is a description. So you can see these fields. It's all the fields that we support in the different formats. So this is when we log to journal, how it appears on journal, how it appears in log format, and how it appears in JSON. And here you have all the fields, about 50 or something, that we have added. So that all the information about alerts, about response times, or whatever it was on the access log, the client IPs, remote IPs, etc., everything, including streaming, everything is included in the fields. For this to be feasible, we had to create a new command. I think it is, no, it's not here. It is here. So we created two new commands that are available. One is log to journal, and I will explain this in a moment. But what I want to show you now is the logger of Netdata. The logger of Netdata is systemd cat native. So there is a command already shipped by systemd that's called systemd cat. This command can take a pipe of whatever input, so you can pipe some text file to it, and it logs it line by line. The problem with this is that it doesn't support structured logs. So if you have scripts and stuff, how do you log in a structured way? So we created the systemd cat native. This command takes input that is like this. So you say syslog identifier equals my application, and this field equals that value. And then to terminate a log event, you just send an empty line. And then another such block below is the second line, the second log event, and so on. So this thing, systemd cat native, reads this kind of input and is able to send it to systemd journal. We have added the following options. We use for Netdata applications, we use the log as Netdata. So this inherits via environment variables, whatever Netdata is doing. So you configure the logging in Netdata, and systemd cat native will inherit it, if it runs under Netdata, of course. But if you run it manually, then you can say, and this is what I want to show you, because we added the ability for anyone to push any kind of logs structured into systemd journal. So the idea is that you can say, I want a name to a namespace or a path. A path is the socket that systemd journal is listening. If you don't say anything, or if you say a namespace, it figures it out by itself. But you can override the default if you want. And also, it can log to a remote journal, to a systemd journal remote. Using the certificates that systemd journal upload uses. Now, the idea is that this command is quite powerful and easy to use. You can just give it a sequence of such events structured like this, and this generates all the things that are required for systemd journal to have fields and index everything, etc. Now, what we wanted is to allow sending logs of any application. So let's take Apache Nginx logs. I have Nginx logs, and I want to push them to systemd journal. Since we have this systemd cat native, the only thing that was missing is somehow to parse the logs of system of Nginx, extract the fields, and transform them into this format and send them to systemd journal. So we created this command. This command is log to journal. This command works like this. That's the general idea. So you tail some kind of files, you pipe the output to log to journal with a pattern. Then this is readme is old. I forgot to update it. So the idea here is that the part of shed is now log to journal is able to do it. This is just from yesterday's documentation, let's say. Today, this is capable of doing it it's by itself to do search replace. So the set command is not needed here. And then the output of log to journal, it is in the journal export format that systemd cat native accepts, pipes the output to systemd cat native, and they are sent to journal. If you see it in action, I have here an example. This explains in detail how this works. So actually, I used ChatGPT for the patterns, because as you see here, there is a pattern that you need to provide. So I explained to ChatGPT that I have this web server, I need this pattern. And it gave me the pattern. So I took a line. This is a line from systemd journal, from Nginx. And then I piped it to log to journal with a pattern that ChatGPT gave me. And the output of log to journal is this. So you see that it parsed all the fields, okay? Then I saw that here, this is 3 fields actually. It's the method, it's the request, and it's the protocol version. And I asked ChatGPT to improve the pattern to make it better for that. So it did. And now I have the message that has all the things that it had before, but I have also the version, the method, and the URL. Now, when you, in this example, I will update this document because this can be done now without shed. In this example, I was rewriting some of the fields. I was rewriting, I think, this in order to get the priority of systemd journal. So I explained this is how this is done, and I used shed for that thing. I used this. But this is not needed now because log to journal can do it by itself. So the idea is that at the end, you have the priority that you want. And then what you do is that you push it. So once this is done, you just push it. So on this command line, if I go to the end, no, this is still the sed. And then you push it to systemd cat native. Here is the push. So if we go here, we're going to see at the end the systemd cat native. Here, come on, this. So what happens then is that I query the journal to see what journal has written out of this. And as you can see, it has written all the fields. Now this is interesting. So all my Nginx log ended up in journal, structured. This is the script actually to do it. Whatever it's shown above, it's over here. It's the pattern that ChatGPT generated, and the commands actually to achieve it. As I said, the sed is not needed anymore. Now, the good thing with this is that we put it on a test, and actually we created a lab where we have we wrote actually a log generator to generate about 4,000 log entries per second to generate a very busy web server at 4,000 log lines per second. And then we used that script, this script that exists here that I show you. We used that script to push them to a system D. And we have this running somewhere. Wait a moment, let me probably this, but let me refresh this. Yes, and we have it running here. So now you see this is 4,000. So this thing now, you see, these are Nginx logs. So if you go here, you will see byte sent, the referer, the user agent, the HTTP version, the method, the remote. These are artificial now. These are random IPs, etc. The user, the response code, the family. We added this in order to have a filter, let's say, for this. The URL, priority, the syslog identifier, etc. Even the file, where it is. Where is it? Journal, no. I think we had added also the file. The journal Nginx log file, no. It's not here. It was in a test. Anyway, so the idea is that you have your Nginx logs in a data. Then what we realized is that at this scale, you see I'm saying just 5 minutes. At this scale, the journal system, the journal becomes quite slow. So if you had an hour or 2 hours or 6 hours, it was at this rate, at 4,000 logs per second, becomes unusable. So we did two more changes to our user interface to speed it up. The first thing, it's not visible at this rate because it's just 5 minutes, but let me go to 10 minutes that I think it will become visible. So in this rate, the first thing that you see is that you have some lines that they say unsampled. So usually what we do, so you see here that this 1.2 million entries. So for this 1.2 million entries, we had to read each one of them, then traverse all the fields to actually generate this kind of stuff here. So that we can have the counters, these counters, right? You see they are live. We can have these counters. So the problem here is that if you do way too many of them, then systemd journal is slow. So now the unsampled means that we counted the lines, but we didn't update the counters. There is a feature missing on our front end. This information about what unsampled means, etc., will appear here. So we are developing that thing to add this information here. So if you zoom out more, then even counting the lines is problematic. And now we have another one that is called estimated. Estimated is small. We're going to fix the color, guys. Sorry for that. The colors of both estimated and unsampled are going to be gray. So if you zoom out more, you will see that most of the work is not actually done. So last hour, it's not actually done. So you see that only this, we actually did the work. For all the others, we estimated the work. Of course, we sampled a lot of information across the thing, and we also collected a lot of information across the entirety. This is the info, This is the notice. So we spread the errors. So we spread the calls, the sampling across the entire duration. We sampled aggressively the end so that you can have good indication of what's happening. And for the rest, instead of doing the heavy lift and actually waiting minutes for this to wait, we sampled part of it and we estimated what is going to happen. So, of course, if you zoom in, as you zoom in, this thing changes and more and more become, you see estimations vanished now completely. So let's go back. Here are the estimations. You go in, it's a threshold. We have a threshold about 1 million entries. At 1 million entries, we don't estimate. We run it. Now, this is quite different if you check the other monitoring logging solutions like Loki or Elastic. They sample very few lines. Elastic, for example, samples the last 500. The Loki limits significantly the number of fields that can be indexed, especially because it shows you lines here like Prometheus, it's a line from a time series database, not from the logs. So what we try to do here is give the full flexibility of systemd journal that indexes everything that people have, while at the same time being able to work with it at volume. This is tricky. It's not easy. And systemd journal needs some love. There is some more work that can be done to improve it. But the output, I think, of what we are talking now is pretty workable. So you are seeing here, this is 12 million. Wait, this is 3. This is, yes. This is 13 million entries, right? And it's still workable. Okay, it took some seconds to be completed, but it did it. So this changed the unsampling, the sampling of the requests and the estimations are already in the nightlies and you're going to have them tomorrow. So this is pretty much. I don't know. We have more time. You have questions. I'm not seeing the questions. Are there any questions, guys?
So far on the chat, there's nothing coming up. But yeah, now it's the time to open to see if anybody has any question they would like to put in or to raise.
So for sure, up to now, we are trying to make systemd journal D as functional as possible and at scale. Of course, still 12 million or 13 million lines are not a lot. And this depends, so the performance you are going to get, you understand that I'm just seeing just 2 hours of it. If I go to 6 hours, this will not finish, it will time out in a minute. Now, this is a small VM, of course. We have it in a VM that has 8 gigs and just an SSD, 8 gigs RAM, and an SSD for this. Journal D is extremely intense, very intense I/O, and it uses the system RAM. Although it's free, it's assumed that's free memory. It uses all the available memory as cache. So the whole point is when you centralize logs with systemd journal to have fast disk, you can have a RAID 0 or something there, or spread evenly across multiple NVMEs, or even if you can have a lot of memory. The memory will appear as free memory, but it's going to be caches for. So this timed out. It didn't go beyond. This is another fix that we did. If we had this message on the top, it would say that the query timed out. So it returned partial data now. Of course, this is now, all these are visible only when you have such a busy 4,000 log entries per second steady, forever. It's an extreme case for systemd journal, but still we wanted this to perform. This is why we did this test. What are they saying, Andre?
Okay, we have one question here from Andre. This is related with alerts. So it's around UPS collection, some warning about after a minute or two not being able to collect. And what Andre was saying, he wanted to adjust to have have a warning if UPS metrics stop being collected after 15 minutes to avoid constant flow of emails.
Oh, so the first thing is that we should do it ourselves, Ilya, on the UPS metrics. Please increase the delay to 15 minutes because it's flipping all the time, and people get a lot of emails. To do it, it's very simple. You go to when you receive the alert notification, it says the line, etc., for the file that this alert comes from. You need to edit this file with edit config. So you run it as in a data edit config in the alert file. It copies it to it as in a data, and then and it opens an editor. When you open the editor, you find the delay and you increase it, the app delay, to 15 minutes. That's it. And you save it, restart the data, or I think there is also a way to reload it. SIG-USR1, I don't remember. But restart the data and it will take it. So it will not be flapping all the time. So the alert will be flapping, but you will receive notifications only if it stays on for 15 minutes. This is what the delay is doing.
Yeah, we also have here Fotis sharing the link to the else configuration reference. So you'll find this parameter attribute that Costi is speaking about on that. Yeah, but we'll also do the work to review the default configuration to make it not flapping.
No, the delay, because come on, if it is... Okay, we'll check it later. But the defaults, guys, if the defaults bother you, this is important. Speak on the Discord, on GitHub. Speak. We want the data to be out of the box as best as possible.
Yeah, this feedback is important for us to fine tune the configurations. Yeah, and we have one. It's not properly a question because I think the user could not kind of express it very well, but the user was saying, I was thinking about how to make this work with a device that needs a syslog server, but I'm not sure. Let's see if...
Let us rely a lot of help, yes. So,
I'm not sure if this... Could you add a second detail?
I was thinking about how to make this work with a device that needs a syslog server, but couldn't nail down a question. So I think that systemd journal acts as a syslog server. The problem with syslog server is that it has only 3 fields. It's the message, the timestamp, and the priority. I think there is also a facility. 4 fields, that's it. If you are asking about a remote server or a local server, how to from a box to send something to journal, or from a remote server via syslog to send something to journal? What's the question? Anyway, if it is from a local server, then the systemd cat native command is available on all systems that Netdata is installed. It's out of the box. The log to journal is also available everywhere, except I think because we use this pattern, this PCRE2 library, PCRE2, and I'm not sure if it is available on all operating systems. But if it is, if this library is there, log to journal will also be there. So the second question, installing data inside TrueNAS scale. Last night, update TrueNAS. Wow, they removed it. So I don't know. This is probably a question for TrueNAS. So they had the data inside and now they removed it. I don't know why.
Yeah, probably something to be raised directly with TrueNAS. So just checking if there's anything else in terms of questions. Okay, we have a follow-up from the other question about syslog.
I was thinking journal being compatible with syslog. Okay, so device and... Yes, of course. Just send the logs if you have any kind of logs. Journal.d is a syslog server. But if you want to send custom logs, so you have a log file, and let's assume that it is from HA proxy or from Nginx, from Apache, and you want to push it to Journal.d and have the Netdata UI actually access it and view and you know to see the errors and whatever else, then we provide now the tools. Tomorrow you are going to get it. They will be in the night today. Log to journal and systemd cat native, and it will be installed together with Netdata. You don't need to do anything else. Just write a script, a wrapper, like the document that we have. I will update that now just to make sure that it's up to date for the latest developments. This way you can move your logs from the log file to systemd journal in a structured way with all the fields there and fully indexed.
Okay, cool. So I think we have a way forward for this user. Just waiting a bit more to see if any other question pops up. Okay, yeah. The user is saying that you'll dig into the device and see what he can do. Yeah, if he has any feedback on that, yeah, feel free to share it with us on Discord, a GitHub discussion, or yeah, any way you want to reach out to us. So probably to complete these office hours, just to complete with the questions that came from the community, there were probably just three kind of things to highlight. There were more questions, but these were the main ones. So we had a user that was trying to do silence some alerts to keep out having the notifications being sent on those. This was on a data agent, and the approach for initially was to put these alerts to silent. Of course, these to silent will need to be done for each alert. So the recommended way was to say use the enable alarms config, where you can put like the exceptions, which alerts you don't want to be enabled. So use like as an exception, you can configure that on the LCD file. And there's also an important point. If this Netdata agent is streaming to a Netdata parent agent, you need to check if you want to have the else running on both. Probably here, the only advantage is to have a failover in case the parent goes down, you still have the alerts on the agent. Otherwise, you'll be having duplicate alerts. But if it's that scenario that you want, if you have else running on both, you need to disable these configurations that you do on one agent. You need to do it on both to make sure these alerts don't come up. The other one was about functions not being process not being available on some system. So here, where is the functions processes linked to? It's linked to the apps plugin. If you go to this presentation, you'll see even the new added functions, which plugin or collector is linked to the function. So for you to be able to see the functions on Netdata, you need to ensure these plugins are enabled and are running. So that way, the functions will become available on the UI directly. So, and to enable and disable plugins, we have like a reference on where you can do it, either on the Netdata conf file or the specific orchestrator plugin files. So that's what you need to check. And the last one. So we had a user that wanted to get Caddy web server JSON log files into a chart. So he wanted to plot these logs into a chart. And we needed to have a kind of a mapping to see which are the available fields. But our web server log plugin or collector was not being able to handle parsing nested JSON or support nested JSON structures. So we made a PR. This is already merged. It's already available. The user already tried it out and is happy with the results. So if you want to parse this type of logs or this type of things into a chart, plot them into a chart in Netdata, you can use this information. So there's a reference to the web server log file that you want to see. That's if you want to see the details on this. So that's it. I see some feedback from Milia actually on the two NAS question. So let me just pop it up because we were speaking this a moment ago. Okay, so there's an hint to some probably conflicts with manual installed Netdata and how the Netdata was removed. So yeah, in 23.10, this Netdata was already a backend system stats for TrueNAS, so it should be available on those. Yeah, but yeah, you still need to ask the TrueNAS guys. Yeah. So that completes the what we had to share or to present. So, like lastly, it's just one thing. For the next office hours, we are trying to bring a different setup. So let's see if we can manage to bring it for in 2 weeks' time. Stay tuned for news around that, and hopefully, if it's a successful office hours, we will do more of those. But yeah, it's kind of a surprise. So stay tuned, and we'll be sharing more details soon on those. Let me just do a double check on the chat. I think everything is covered. Yeah, it is replying to Andre. So again, thanks for your time. Thanks to Costa for this detailed guide through on all the changes around the functions and the systemd journal log. So as I mentioned, if you have any feedback on functions, there's a GitHub discussion about that. If you have any other feedback about anything else, feel free to jump to our Discord or even start a GitHub discussion yourself. So we love to hear your feedback, and we'd gladly jump on anything that we'd like to bring to the product to help you troubleshoot and do your job. So if that's it, thank you guys. See you in 2 weeks. Have a great week. Bye bye.